Hello students, let us solve one more problem from this year GATE question paper. So they have given you a neutral conducting sphere of radius r which is placed in the uniform electric field. So this is the standard problem and they have given you the expression for potential for this problem and they say which of the following options are correct. Okay, so let me first write the expression. So expression is V r theta V naught minus E naught R cos of theta, and then this is a minus minus plus E naught R cube upon R square cos theta. Okay, so this is expression. And now this is the option number A says the induced surface charge density of the sphere is proportional to sine theta. Okay, we have to calculate the induced surface charge density. Okay, before that, if you see this expression, this first term, this is due to the external field in the dead direction. So this is the due to external field. This is due to external field, and this term is due to induced charge. Induced charge. Now, if I say I have to calculate the induced charge, so you know induced charge is given by minus E naught del V upon del N, or here we have to keep R because I have to go perpendicular to the surface. Okay, inside the electric field is zero, conductor. So this will be I will take ER theta. Okay, in direction of this one. So now if I find the value of this one, so this gives me E naught, differentiate this equation. So this will be 0 minus E naught cos of theta. Okay, and then you have this one E naught. Okay, so if I differentiate, this will be minus 2 R cube upon R cube cos of theta. Okay, now if I find this at R is equal to R, this will be minus E naught. Okay, this is cancelled, so minus 3 E naught. Here E naught also there, multiplied. Here E naught also there. Okay, so this gives me 3 E naught cos theta. So the total is 3 E naught cos theta. Okay. So the option A says the induced surface charge density of sphere is proportional to sine theta, but here it is proportional to the cos theta. So this option is not correct. This option is not correct. Okay. Let us go for second question. As R tends to infinite, E is E naught E cos theta R cap. Okay. So let us first calculate the electric field. Okay, so I have already calculated the R component, so I have already ER. Okay, I have already calculated the ER minus del V by del R. So ER is what? ER is this one, minus minus, so this become E naught cos of theta, okay, plus 2R cube upon R cube E naught cos of theta. Okay, this is the component of electric field, total component of electric field in the r cap direction. Now, see, they're asking at r infinite. So obviously, without solving, also you can tell directly because the sphere is in the uniform electric field. So if you go far away from here, so you will only be left with the external electric field. Okay, this induce effect will not be at far distances. Far distances from this object, there will be only uniform electric field. So anyway, we are calculating. So you have ER. Okay, now let me calculate E theta. Okay, let me again write the expression. So we have a V R theta V naught minus E naught R1 minus R cube upon R cube cos theta. Okay, so let me calculate now E theta. So E theta is minus 1 by R del V by del theta. Okay, So what will be the if I differentiate this one, okay, the first 0, then you have a minus, okay, E naught R 1 minus R cube upon R cube cos theta will be sin theta. Okay. Now I have to check this expression at infinite. So if I take R tends to infinite, so ER will be what? This term will become 0. This will be only E0 cos theta. Okay. Similarly, if I write this one, okay, so this term will be only 0. So if I calculate E theta, this will give me only minus E naught, okay, E naught R is there, okay, R sin R, so R will be 1 by R will be cancelled. So this will be only, you have the only E naught sin theta. Okay. So now if I calculate the total electric field E, this will be what? This will be R cap ER plus theta cap E theta. Okay. So if I put these values, this gives me E naught cos of theta R cap minus E naught sin theta. This will be what? Theta cap. Okay. Now if I take common this one, so see, this is of course not E cos theta. You have one more term remaining here. Okay. So this option is also wrong, and you can solve this one. This will give you what? E naught. If you take E naught cos theta, if you take E naught common, so this gives you R cap cos theta minus sin theta cap, and this is just a Z cap. So this is the E naught Z cap. Okay, so obviously the far from object, the electric field will be only external electric field. So this option is also wrong. And our third option says the electric field at any point is curl free for R greater than R. Okay, so we know the electrostatic fields are conservative. So obviously del cross E should be 0. If you can check it. So this option should be the correct. Okay, and the last option says the electric field at any point is divergence free. Okay, so if you go far from outside, okay, this is rho upon 0, so rho is already 0. Okay, outside there is no charge. Okay, so divergence should be electric field at any point should be divergence free, so divergence should be 0. Okay, divergence should be 0. Okay, so anyway, this is the electric field in the straight lines. Okay, this electric field in the z direction, so there should not be divergence. So this option is also correct. Okay, so option C and D are correct, while A and B are wrong. Okay, hope you like the solution. Thank you very much. Subscribe my channel.